welcome to another lesson on introductory statistics. Today we are going to be looking at something quite different from what we have been studying as regards sampling distribution, and testing of hypotheses. You see, in the previous lessons, we have been preoccupied with testing a given null hypothesis on the basis of test statistics that are constructed from samples. And we use this test statistic to either reject the null hypothesis, which is specifying some certain conjecture about a population parameter. And we've seen how this whole process can be navigated. And we actually observed that in all of these cases, the distribution of a sample is actually what defines whether or not a testing problem is going to take a particular shape or not. But in this regard, such as the one we're going to consider in this lesson, there's going to be a shift or a departure from that paradigm where we assume that a known probability distribution is generating the sample that we're analyzing, or that the sample that we are analyzing and on the basis of which we're going to draw conclusions about the population parameter is known. So that has to do with the concept of parametric statistics. Okay, in non-parametric statistics or tests like we are going to consider now, what we are going to consider is a situation where we do not hypothesize any known distribution for the sample that we are analyzing. Put differently, we do not hypothesize a parametric probability distribution that the sample that we are analyzing and on the basis of which we are going to draw conclusion on some hypothesis, we do not say that we know that sample. That is what is going to give rise to the concept of non-parametric statistics and test. Okay, non-parametric statistics and test is actually a major area in statistical theory, and what we're going to do in this lecture is actually to introduce us to this area, because the former methods and of course the various procedures used in developing these test statistics are a little bit advanced, but it is within the realm of our study to get introduced to these concepts. So let us quickly see what our objectives are today. Now, we have a very singular objective for this class or for this lesson, and is to explore the concept of non-parametric statistics and non-parametric tests. So that is what we are going to do in this lesson. So far in our previous lessons, our discussion have been on parametric statistics, where we normally hypothesize a known family of distribution for any data we analyze or that we test. Okay, so we hypothesize a distribution, a parent probability distribution that we often assume or that we often say that the data that we're analyzing follows. Recall that for us to analyze any data, that data has to represent a certain real-life phenomenon. For example, the marks of students in a class, the age of students in a class, the height of students in a class. Now, from the entire class, we will draw a sample. Once we draw a sample from the entire class, the next thing that we do is to, on the basis of the sample, make judgment for the entire class. For example, we can hypothesize that the average height of students in the class, that is the population, the actual average height of the student in the class, an investigator may believe that it is 6.5 feet. But we're going to collect a sample of maybe 10 students out of over 10,000 that may be in that particular class. And then we estimate the sample average of those 10 students, and on the basis of the sample average of those 10 students, begin to see or test whether the conjecture made by that investigator that the sample, that the population, the average population height is 6.5, whether it is true or not. So that is what we do in parametric statistics. Okay, whether we are testing the in the case of the mean, which I just explained, or we are testing for goodness of fit, or we are testing for independence, or we are testing for the differences in the means of several populations. By several, we mean populations that are greater than 3, in which case we involve the analysis of variance test, which we have dealt with. Okay, so that has been the preoccupation. But in non-parametric statistics, we are going to see a different angle to our testing problems. So in this lesson, we're going to explore non-parametric statistics and consider some non-parametric tests, okay, under the assumption that the distribution of our sample data are unknown. Okay, so in non-parametric test or statistics, we do not assume that we know the distribution of the sample. For example, in the case of the age of students, we can easily assume that it is normally distributed. But when we move from that angle and come into non-parametric statistics, we do not assume that we know the age, the distribution of the age of the student anymore. So we are going to start by looking at what non-parametric statistics is. So non-parametric statistics is a branch of statistics that does not assume any specified probability distribution for the data that is being analyzed. So for any data that we're analyzing, we do not hypothesize any known distribution that they are following. Recall that before we construct a test statistic or carry out any analysis of any sort, we first of all assume or conjecture that the sample data that we're analyzing is coming from the normal distribution, the Poisson distribution, or the hypergeometric distribution. Or we can say that the distribution or the data set was generated from a Poisson process, a binomial process, or an hypergeometric experiment. And on the basis of that, we begin to tag these distributions to this data, or we begin to claim that this data follows these distributions. So when we do that, we are carrying out what is called parametric statistics, or the classical paradigm of testing. But when we do not make such an assumption, or in non-parametric statistics, we don't make that assumption. We follow an agnostic path that we do not know, and there are reasons for that. And as we progress with our discussion, we're going to establish these reasons. Now, so unlike parametric test, which assumes that the data follow a specific distribution, such as a normal distribution, non-parametric statistics do not make such an assumption, okay, and can be used when the data is not normally distributed or when the underlying population parameters are unknown. So when the population parameters are not known, and when we cannot assume that we know the population from which the sample that we're analyzing is drawn, we have to use the non-parametric test. So the non-parametric test is actually, or the non-parametric statistics covers the area of statistics where we do not assume that we know the distribution of samples or the parameters of the distributions of that sample. So we call it non-parametric statistics. So non-parametric frameworks are often used also when data being analyzed is on a nominal or ordinal scale, or when the sample size is very small. Okay, you see, in parametric statistics, we play with data sets that are numeric in nature, because we need to compute the mean, we need to compute the variance. But when the data set is nominal or ordinal, we can't really do all of that. For example, when the data set involves the names of people or of a town, we can't do that. So we need the data set. Whenever the data set is nominal or in an ordinal scale that shows ranking, we will have to resort to the use of non-parametric statistics, or when the data set, the sample size is very small. So one of the assumptions of the parametric test that we have considered, okay, is that the sample size is relatively large for us to assume that it's normally distributed. We call the central limit theorem. Okay, so, and of course, Non-parametric statistics are also useful in situations where the data violate the assumptions of parametric tests, such as when the data is normally distributed or when the variance of different groups are not equal. For example, in the case of ANOVA, for us to carry out an analysis of variance tests, we often assume that the variances between the groups, okay, the variances of the different groups are the same. But that may not be the case in reality. So we begin to, because parametric test is read in assumptions. We have to assume independence in some instance. We have to assume that the sample is coming from a normal distribution in some instance. For example, when carrying out an analysis of variance test, we have to assume that the different populations are normally distributed and that they are independent and that, you know, the variances are equal. But these assumptions may not be met in all cases. And when these assumptions are not met, we have to resort to the use of non-parametric statistics. So this is actually the hallmark of non-parametric statistics. Okay, so in sum, non-parametric statistics provides an alternative approach to classical parametric statistics and are useful tools for analyzing and testing data when the assumptions of parametric frameworks are not met. So, in sum, non-parametric statistics provides an alternative approach to classical parametric statistics, okay, and are very useful tools for analyzing and testing data when the assumptions of parametric frameworks are not met. This is when we use non-parametric statistics. When the assumptions of the parametric framework is not met, the non-parametric statistics comes in. All right, so as an exercise, I would like you to look into distinguishing between parametric and non-parametric statistics. You can read, you know, some other materials in order to put up a very good and concise essay about this. There are various literatures that are existing that you could read to update yourself in an exercise of this nature. Now, let us look at non-parametric tests. From parametric statistics, we have parametric tests such as ANOVA, chi-square, and of course tests concerning the mean of a single population. So from non-parametric statistics, we also devise non-parametric tests. So what are non-parametric tests? A non-parametric test is a statistical hypothesis test that is used when the data being analyzed does not meet the assumption of parametric tests, okay, such as having a normal distribution or other distribution. In other words, we use a non-parametric test when we cannot tell with specificity that a particular distribution is what? Is normal, okay? When we cannot tell that a particular distribution is normal or not normal. So if we cannot tell it, we're going to be using, we have to then use what is called a parametric statistics. A non-parametric statistic. So when the assumptions of parametric statistics are not met, such as knowing whether the data set from which we construct our testing problem follows the normal distribution or not, we use the non-parametric test. Okay, so let's see more about non-parametric tests. So non-parametric tests do not also rely on any assumption about the population parameter. So there is no assumption. In other words, you know, in the case of testing for the different this mean of a single population, we often make an assumption that the mean is 20, some values. But in parametric statistics, in non-parametric statistics, we don't have any information about the population parameter or the distribution of the data, and are often used when the data is measured on a nominal or ordinal scale. So non-parametric tests are also called distribution-free tests, in the sense that we do not know the distribution of the test at all. So this is basically what non-parametric test is all about. So non-parametric tests are typically used to compare two or more groups of data, okay, to test for differences between two or more variables, okay, or to test for correlation between two variables. For example, like in the case of the Spearman rank correlation test, it's actually a non-parametric apparatus used for computing the correlation between two variables. That is the relationship between two variables, as it were, or the nature of relationship between two variables, as it were. So in most non-parametric tests, we use them to compare two variables, whether they are related or not. Just as we do, for example, in parametric statistics, we'll talk about the two-sample t-test. In the two-sample t-test, we're trying to judge whether there's a significant difference between the two samples. So we also have a non-parametric counterpart for doing that. So they are actually used to test for differences between two or more variables, or to test for correlation between two variables. So in non-parametric test, this is one of the linchpin of non-parametric arguments, is that the actual observations are not used. Rather, the ranks of the observations are used to construct the test statistic. Recall that whenever we want to construct the test, statistic, okay, when we are constructing the test statistic for parametric statistic, what do? We simply find the mean, the standard deviation on the basis of the sample observation that is given to us. We use the actual sample observation to construct the test statistic. But in non-parametric statistics, we do not use the values. Rather, we use the ranks of those values. For example, if the sample I collect is comprised of the age of 3 students, is 16, 18, and 19. If I want to construct a test statistics in the parametric paradigm, I'll find the average of those 3 ages, I'll find the standard deviation. But in non-parametric statistics, I won't find the average of those 3 ages, I won't find the standard deviation of those 3 ages. What will I do? I will find the ranks of those 3 ages first. For example, I'll rank 16. I'll rank 16 as the least, give it a value of 1. I'll rank 17 as the second, give it a rank of 2, and of course give 19 or the last value a rank of 3, and then calculate the mean of the rank as well as the standard deviation of the rank. So in non-parametric statistics, we often use the rank rather than the observations, and that is what gave rise to what is called linear rank statistics. So just as we have our statistics that are based on sample in parametric framework, our statistics are based on ranks in non-parametric frameworks. Hence, they are called linear rank statistics. So, in summary, we have actually explored non-parametric statistics as well as non-parametric tests. And of course, we concluded by noting that the test statistic for a non-parametric test is based on the ranks of sample observations rather than the value of the observation. The takeaway from this discussion is that this is this is another area of carrying out statistical data analysis. In the classical paradigm, which is the parametric statistics, we often hypothesize a known distribution for whatever data that we're analyzing. And then whenever we are testing hypotheses about that data, we proceed in that same manner under the assumption that we know the population. But in this case, we do not assume any known population for the data we're analyzing. So we say it is a distribution-free test or a distribution-free statistics. And of course, when we do that, we proceed by constructing test statistics that do not make use of the actual observations but the ranks of the observations that we are analyzing. So this, in summary, is what non-parametric statistics and non-parametric tests is all about. Thank you for joining me in this lesson. I'll see you in the next